Lecture number 6. Manufacturing Engineering. Automotive Manufacturing. Mr. Sayed Sardorbek. Spring Semester 2020. Contents. 1. Automotive Industry. 2. Production Management in Automotive Industry. Number 1. Automotive Industry. The automotive industry can be described as a backbone in many developed countries such as Japan, Korea, USA, and Germany, while being an enabler for economic prosperity in developing countries like China, Brazil, Eastern Europe, and Russia at the same time. However, the dynamics and uncertainty are increasing heavily by market changes, regulations, customer behavior, and new product technologies. Manufacturing research has to find answers to increase quality of products, flexibility of plants, and supply chain networks, to manage complexity in technologies and variance, and overall to stay competitive even in high-wage countries. In this paper, major technological challenges are discussed and the current state of manufacturing technology and research is presented. Moreover, for each technological and organizational area, future industrial and research challenges are highlighted. Cars represent the pursuit of freedom of each individual like nothing else. The relevance of the automotive industry for economic prosperity and its impact on jobs can be seen in all major markets and countries. Interestingly, both developed and developing countries see this industry as their backbone. While the industry in TRIAD countries USA, Japan, and EU became a high-tech branch, BRIC countries Brazil, Russia, India, and China started with simpler products. In the European Union, about 16 million units are manufactured, which is about 26% of the world's annual production. Hence, cars are one of the most important products with an annual turnover of about €700 billion. There are about 2 million direct jobs and another 10 million in related manufacturing and other sectors within the automotive industry in the EU, including truck suppliers, etc. With its 210 production plants in Europe, the automotive industry exports €75 billion of net trade every year. It is also the largest sector in private R&D, research and development. Investments with more than 5,800 patents in 2011. Being the most important player in Europe's automotive industry, Germany has more than 750,000 employees working directly in the automotive sector in more than 45 plants. The automotive industry in the USA accounts for between 4 to 5% of the U.S. gross domestic product and employed 716,900 people in 2011. In Japan, almost 790,000 people work directly in the automotive industry. It is expected that the BRIC's share of global vehicle sales will edge towards the 50% mark by 2018, and TRIAD and BRIC markets are expected to converge in terms of customer demands and behavior within the next 5 to 6 years. As a matter of fact, China has already become the world's largest automobile producer and market since 2009. The current 5-year plan of the Chinese administration prepares China for a market share of 30% of all cars in the world, and the Chinese government views the development of the new energy vehicle industry as a top priority and has introduced policies and incentives in its favor. The presented figures illustrate the importance of the automotive industry for all major economies. However, this leading industry faces tough challenges due to emission limitations and public opinion, unsustainable surge in petroleum consumption, high volatility and a temporarily low utilization of capacity. In the automotive industry, the number of jobs depends to a high extent on manufacturing, and consequently so does the prosperity of an economy. Facing the mentioned challenges means technological progresses in both product and production. In the following, selected technological approaches are discussed and the current state of manufacturing technology and research is presented. Moreover, for each technological and organizational area, future industrial and research challenges are highlighted. The paper is therefore organized as follows. Firstly, current state and roadmaps of selected core technologies with tremendous impacts on manufacturing are given. Secondly, some key enablers and also organizational issues are presented, before the paper ends with some final remarks. No specific scientific methodology was used to come up with the roadmap. Instead, this viewpoint is driven by an ad hoc method to provide a general assessment as well as a projection of future advanced automotive manufacturing technologies. Number 2. Production management in automotive industry. With a large degree of automation, the automotive industry needs intelligent machines and maintenance solutions to achieve higher productivity, improved reliability, greater efficiency and complete quality assurance. Most machine maintenance today is either purely reactive, fixing or replacing equipment after it fails, or blindly proactive, assuming a certain level of performance degradation, with no input from the machinery itself, and servicing equipment on a routine schedule whether service is actually needed or not. Both scenarios are extremely wasteful. The main barriers for predicting on-condition performance of a complex system include: A. The inability to anticipate unknown faults, particularly for complex engineering systems in which hundreds to thousands of subsystems interact and contribute to the overall system functionality and performance. B. The inability to sustain system functionality and performance in the presence of system anomalies and severe disturbances, especially when the system operates under varying conditions. C. The inability of self-adjusting system configurations to mitigate internal faults and/or external intrusions to achieve survivability. To meet these challenges, automotive factories need to go beyond predictive maintenance to intelligent prognostics, the process of pinpointing exactly which components of the machine are likely to fail and when to trigger service and to order spare parts autonomously. When smart products and machines are networked and remotely monitored, and when their data is modeled and continually analyzed with sophisticated systems, it is possible to reach intelligent prognostics. The picture shows the unmet needs of future intelligent maintenance systems (IMS). IMS focuses on developing advanced degradation modeling and prediction as well as informatics tools for decision support systems. The goal of the automotive industry in developed countries like Japan, Korea, USA, and Germany is to increase sustainability in terms of being profitable, ecological, and socially compatible. New product and production technologies have to be integrated, new cooperations managed, and customer satisfaction increased by localization and individualization, while production costs stay competitive due to smart and flexible factories. Summary. Please take a note this lecture to your draft. We will ask it. If you have any question, you can ask in our Telegram group. Follow the lectures. Thank you for watching.